Alright, so this is trial number 3. We'll see how this goes. Before we get into notes, I'm going to show you some cool apps if you don't have a calculator at home. I know I didn't get a chance to sign those out. So there's always Desmos, which we've used before. You can just go to desmos.com and it'll pop up with this graphing calculator, or you can download their app for free. There's also this thing called Calculate 84 that I just found, and it looks just like the calculators we've used in class. So that's also an option if you don't want to use the ridiculous calculator that is on your iPhone or whatever type of phone you have. So hopefully this app will work right now. If you saw on Canvas, I should have uploaded the 6-1 skills practice. We're just going to review some of the problems that we might have done last week with Polygon angle sum theorems. So before we get into those problems exactly, I wanted to do just some review of notes. So when we talk about finding the sum of the measures of the interior angles, so the inside of it, any inside a polygon, we came up with that we looked at all the triangles within a polygon. And so we came up with the n minus 2 times 180. And the 180 came from the sum of the measures inside a triangle. And then if we want to find the measure of each angle, so like if we're looking at a singular angle in a regular polygon, so that's when all the angles are congruent, that's when we take the sum, so the n minus 2 times 180, and divide by n, the number of sides. Alright, so the sum of the exterior angles, so the outside of any inside a polygon, is always 360. It's never going to change. And then if we're finding the measure of each exterior angle, only in a regular polygon, so only when all the angles are congruent, that's when we take 360 and divide by n. Okay, so that's all you should need to know to complete all these problems to the left here. If you want to pause and get those down if you haven't already. But I'm going to continue over to these. So for the first part, it says find the sum of the measures of the interior angles. So when I'm talking about the sum, there's only two formulas, so either this one or this one, okay? And then it specifically talks about interior angles, so I know I'm going to use the wrong utensil, n minus 2 times 180. So with my first one, I have an 11 gone. So that means my n equals 11. So I'm going to have 11 minus 2 times 180. And I'm actually going to erase this because I didn't give myself enough room. But when you do 11 minus 2 times 180, you get... Sorry, I didn't calculate this before. 1,620. So that is the sum of all the angles in an 11 gon. Then if I have a 14 gon, I would take 14 minus 2 times 180. So really you're taking 12 times 180. And you get 2,160. And then the last one with a 17 gon, 17 minus 2 times 180. $2,700. Alright, so those should be pretty straightforward, pretty easy. The next set of problems says find the measures of each interior angle in each regular polygon. So when we say each, that means we're talking about a single angle. So we're going to use the n minus 2 times 180 divided by n. So for a quadrilateral, that's what this unit is called. That's the four-sided shapes. So that's when n equals 4. So I'm going to take 4 minus 2 times 180 divided by 4. So that's when we get 90 degrees, which makes sense because a square would be a four-sided shape, and it's also regular and all the angles are 90 degrees. Next is a pentagon. A pentagon has 5 sides, so I'm going to take 5 minus 2 times 180 divided by 5. And for that, you would get 108. Promise my handwriting's going to get a lot better, probably on Wednesday, because my stylist is coming on Tuesday. So, on Wednesday, watch out. For a dodecagon, I would have told you this, but it's a 12-sided shape. Don't worry about memorizing up past a heptagon. So, you only have to remember up to 7 sides. So, for 12, we would have 12 minus 2 times 180 divided by 12. And for this one, you get 150. So reminder, we were just finding the measure of each interior angle. So we weren't finding the sum. That's why we had to divide at the very end. All right, so for number 7, we just have the directions of solving for x. So we're not really told anything about the angles besides angle A is 2x minus 15, angle B is x. So I know, however, that if I take the sum of all of these angles, that would be the sum of a quadrilateral. So quadrilateral has 4 sides, 4 minus 2 times 180, and you get 360. So hopefully you've memorized that a quadrilateral has a sum of 360 degrees inside for the interior angles. So I know that if I take angle A, angle B, angle C, and angle D, they should all add up to 360. So I'm going to take 2x minus 15 plus x plus 2x minus 15 again plus x equals 360. I'm going to combine my like terms. So I get 2 plus 1 plus 2 plus 1 would be 6x. Then I'm going to take minus 15, so minus 30 equals 360. Then add 30 to both sides, and I get 6x equals 390. Divide by 6, and x equals 65. Okay, so that first step is right here. It's finding the sum of those interior angles. Once you find that sum, then you're going to take all the angles, add them up, and set it equal to whatever that sum is. And then you should be able to solve for x. Okay, I think I have one more, just like that one. Ah! Where's my undo button? Oh, there it is. As you can tell, I'm still getting used to this drawing thing. So if I start with problem number 8, I have a 1, 2, 3, 4, 5, 6-sided shape, so that's a hexagon. I know hexagons have 720 degrees on their interior angles for their sum. If you didn't memorize that, then all you gotta use is this formula and you're good to go. So I know that if I take 110 plus 8x minus 1 plus 5x plus 36 plus 116 plus 7x plus 19 plus 6x minus 2, that they should equal 720. So that's what I'm going to do. I'm going to add them all up real fast. Hopefully I have enough room. Ah, 116. Ooh, running out of space. Equals 720. All right, now I'm going to combine like terms, my numbers. So if I take 110 minus 1 plus 36 plus 116 plus 19 minus 2, I should end up with 278. Now I want to check my math. And then if I take my x's, I have 8x plus 5x plus 7x minus 16x. No, minus 6x. Oh. No, plus 6x. Jeez, I cannot read my own handwriting. So, let me do my math again. I should get plus 26x. Sorry, this problem is whack. All equals 720. So then I'm going to subtract 278. And I get 26x equals 442. And so I divide by 26. And x equals 17. Alright, sweet. Got through that one. Alright, so if I move down and I think about the measure of an interior angle, so I'm talking about a single interior angle of a regular polygon is given. Oh, so they're going to give us that angle. Find the number of sides. So this time I don't know what n is. But if I'm talking about a singular interior angle, that's when I know I'm going to use the n minus 2 times 180 divided by n formula. But instead of knowing what n is, that's what my angle measure is going to equal. So if I start with this first one, I know that if I take n minus 2 times 180 divided by n and set it equal to 108, then I can figure out what n is. So this is like in trig, where I'm going to multiply by n on both sides. So my n's cancel over here. And then I get n minus 2 times 180 equals 108n. Then I'm going to distribute that 108 or 180, and I get 180n minus 360 equals 108n. Then I need to combine my n's, so I'm going to subtract 180n from both sides. And I get negative 360 equals negative 72. And then if you divide by negative 72, you get n equals 1. No, that's not right. You get n equals 5. So that means in a pentagon, the measure of the interior angles is 108. Alright, so if you want to pause and try number 10 and number 11, I would recommend doing so. I'm going to erase this equation. But for these two, I'm going to do the same thing. So I'm going to have 120 equals n minus 2 times 180 divided by n. First, I'm going to multiply by n on both sides. N's cross out over here. And then I'm going to have n times 120. I'm going to write it differently. equals, and then after, if I distribute the 180 like I did before, I get 180n minus 360. Now I'm going to subtract 180n to get my n's on both sides, or on the one side, and I get negative 60n equals negative 360. Okay, then you're going to divide by negative 60 on both sides. And n equals 6. Okay, for 11, let's try green. So I have 150, so I'm going to have 150 equals n minus 2 times 180 divided by n. Multiply by n on both sides. You get 150n equals 180n minus 360 after I distribute. Subtract 180n on both sides. And you get negative 30n equals negative 360. After you divide by negative 30, n equals 12. Perfect. All right, just a few more. So, wow, that's a lot of work. Really messy. If I look at 12 through 14, my directions are find the measures of each exterior angle in a regular polygon. So when I think about finding each exterior angle in a regular polygon, if we look back at their first notes, I would be thinking about this equation, 360 divided by n. So going down to number 12, an octagon is a 8-sided shape, so n would equal 8. So I'm just going to have 360 divided by 8. And I get 45 degrees. So if I took an octagon and it was a regular octagon, then that means all the exterior angles are going to be 45 degrees each. 13, I'm dealing with a nonagon, which is a 9-sided shape. Again, you only have to memorize up to a heptagon. You don't have to know what a nonagon is, but hopefully you've seen it enough. You kind of know what it's a 9-sided shape by now. So I'm going to take 360 divided by 9, and you get 40 degrees. Number 14, I have a 12gon, so that's just when n equals 12, or a 12-sided shape. And so I'm going to take 360 divided by 12, and I get 30. Okay. Now some of these, like, you might get decimals, and that's completely okay. You can have a degree that's not a whole number. That just means it's not a number that would go evenly into 360, which happens. So don't freak out. But I think we have one more at the very top. If I can erase my line. Oh yeah, number 15. Let me get rid of some of this other stuff. All that nice work that I did earlier. So with 15, it's really number 15, not number 17. Let's get rid of that. So 15, we're solving for x. Now, all of these angles that I'm dealing with now, these are what we call these exterior angles. They're the angles outside of the polygon. So the sum of the exterior angles, why is it doing that? Is always 360 degrees. So if I take all of these angles, that I've already highlighted, and I add them up, they should equal that 360. So it's kind of like the problems that we did for 7 and 8, except now we're doing it with the exterior. So if I take 7x plus 4 plus 5x plus 4, and keep going, I think I got them all. 1, 2, 3, 4, 5. Yep, okay. Those should all equal or add up to 360. So I'm going to combine my like terms. Start with my x's. So 7x plus 5 plus 4 plus 9 plus 4. And I get 29x. Then if I look at my numbers, I have 4 plus 9 minus 6 plus 1. You should get 12 equals 360. Subtract 12 from both sides. $29x equals 348. Divide by 29, and we hope that it is correct. And we get x equals 12, which is in fact correct. Alright, so we are going to have a standard check over this topic on Wednesday, so make sure you're watching these videos and taking notes. Today you're going to have a just short little quiz over one of the problems in this note sheet, so making sure you take down all the notes every day is going to be helpful for always getting those just short little, almost like attendance check quizzes correct. So nothing to worry about at all. It's just for me to make sure that you guys are actually logging on and watching these videos, because they do take a lot of time to make. So yeah, if you guys have any issues, just let me know through either Canvas, email, or even the Remind app. I'm always here to help, and I don't want anyone to feel like they're even more lost with this avenue. So yeah, like and subscribe my video. So see you tomorrow, and we'll start something new. Okay, bye guys, miss you.